Welcome to Emilac Online Tutorial. Before us, we'll be looking at this topic, heat energy, and under which we'll be treating questions on specific heat capacity. Now, one of those questions is this: that calculate this final temperature of 2 kilograms of alcohol at 25 degrees Celsius when 20160 joules of heat energy is added to it. And we are given that the specific heat capacity of alcohol is 2520 joule per kilogram per Kelvin. Alright, if you are new to my channel, please kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos. And if you're on Facebook, please like, share, and drop a comment as regarding to this topic. Alright, now first, let's start. Now, first of all, when you encounter questions like this, it's very important that you write out the parameters in the question. Now, first of all, we are given that the mass of the alcohol, let's just signify it as MA as 2 kilogram. Okay. Now for the fact that this it means this is the initial temperature. So we can denote that let us say maybe T1, or you can just say theta1, depending. You have 25 degree centigrade. Now, when 20, that probably 20,160 joules of heat energy, so we write that out. The heat equals 20160 joules. Okay, and we are given that the specific heat capacity equals 2520 joules per kilogram per Kelvin. Now, the next thing we need to look at now is to recall the formula for specific heat capacity, and which is given as H equals what? The mass of the substance. Now the specific heat of the substance and change in temperature. Now this change in temperature is denoted, that is change in theta, which is theta2 minus theta1, which can also be written as probably T2 minus T1. That is in the case if this is written as change in what? T, which is what? The temperature. Alright, now the next thing we look at now is, and we are told to find the final temperature, which means either T2 or theta2 is what we're looking for. Now, rewriting this formula with regards to this, we have that H equals MC, then in brackets, parentheses rather, T2 minus what? T1. Okay, now let us now fix in all these parameters into the equation. Then we tend to solve for what? Theta2, which is what? The final temperature. Now we're given that the heat, you write that out, 20160 equals, now the mass of the alcohol is 2, then times the specific heat capacity, which is given as 2520, okay, then times, then open parenthesis, the final temperature, which we are actually looking for, theta2 minus theta1, that will be 25. Now close. Now what we need to look at now is how to resolve this or simplify this. Okay, and by calculation, 2 times 2520 will give us 5040. So here we have 21606 equals 5040, then open bracket theta2 minus 25. Alright, so since 5040 is the coefficient of this term, what we need to do now is to divide both sides by the coefficient of the time we're actually looking for. We have 5040, 5040. That's 20160 divided by 5040. So here we have 4. This will eliminate this, then equals theta 2 minus 25. Now since here we have negative 25 here, what we just need to do is add 25 to both sides. Add 25 here, add 25 here. Now this will give us 29, then equals the whole of this will give us what? 0. We are left with what? Theta 2. So our final temperature, which is theta 2, is now what? 29 degrees centigrade. Alright, thank you and God bless. Bye.